caliper yours.
Good morning. This is Bill Acker with New York Best, and welcome to the webinar today on Standard Interconnection Requirements in New York State, updates and insights on proposed SIR changes. As many of you are aware, this year is a very exciting year for energy storage in New York State. The governor recently announced significant targets of 1,500 megawatts by 2025, a 30,000 job goal in the state, and very important steps of financing and monetary support behind that, and some processes to develop the market rules further under the REV process to advance the energy storage industry in the state. In order to do that, it's very important that we address the various different aspects of being able to put energy storage onto the grid in New York State. And that, of course, includes the interconnection process to the grid. So to do that, the state has been taking steps with industry to develop and advance new changes to the Standard Interconnect rules to make sure we understand we're talking about rules for devices under 5 megawatts to connect through utility and distribution grids. Not the large-scale devices with ISO interconnect rules. And today we're going to talk about those proposed changes for the rules, and also we have guests from Con Ed to talk about how you do the interconnect process now and lessons learned from that. So we have a very exciting webinar for you today. A little bit of logistics before we start. We have an interactive webinar. We will be broadcasting for a little while, and then we have a question and answer period. That question and answer period, we will be using questions that you input through the chat box of the web application that we're using. So please feel free to enter questions throughout the course of the webinar, and we will be collecting those questions and asking them after each of the speakers, after the full set of speakers are done talking. After the webinar also, there is a survey which we encourage you to fill out. Obviously, we're always looking for feedback on the webinars that we provide, so we do encourage you to do that. And lastly, this webinar is being recorded. So if you want to rewatch it, or if you have colleagues that want to see it, you can access the webinar in the future. With that said, this webinar is part of the soft cost program from NYSERDA. And I'm going to ask Ben Falber, who is the program manager for the soft cost program from NYSERDA, to introduce the soft cost program and the efforts that NYSERDA is doing to set the stage here. Ben?
Great. Thank you, Bill. Yeah, so I'm a member of the storage team here at NYSERDA. That also includes Tony Abate and Jason Doling, if you've ever worked with them. We're implementing a multifaceted program here, which is mostly focused on reducing energy storage soft costs here in New York, with a focus on distributed energy storage like Bill described, mostly on the distribution system. These are the non-hardware costs that include permitting, interconnection, customer acquisition, business model and revenue uncertainty, and if it exists, a lack of confidence in the technology performance or the revenue, which can really influence financing costs. Right now, we are doing this with two main investments. We have the soft cost reduction program, and we have the demonstration project funding opportunity. And I say right now because of what Bill mentioned right at the top, where we have this deployment target now of 1,500 megawatts by 2025, and later this year you're going to see a roadmap release that really details what energy storage is suited to address in New York, the actions we're going to take to pursue and make that target happen. And this is all happening under the Clean Energy Standard, which mandates 50% renewable by 2030. So the storage program is evolving, but right now you have these two main investments that we've undertaken. So the value stacking pilot project solicitation, that's for projects stacking multiple values, serving the customer, the utility, the wholesale market. 50% cost share max. Funding is available for feasibility studies. These are really bellwether demonstrations that are meant to demonstrate and inform the market on what energy storage can do and the kinds of value that it can access. The other aspect here is the soft cost reduction team. We've created a team here to reduce soft costs by 25% in 3 years and 33% or more in 5 years. CUNY, which is working very closely with NYSERDA. A lot of work has been done to streamline the permitting process, especially in New York City, and then it's going to expand outside of New York City as needed with an initial focus on outdoor permitting. Streamlined guidelines for outdoor permitting of advanced technologies will be coming out shortly. We know this is a huge issue for a lot of installations. CUNY's also been working with Dean VGL and Meister Consultants Group on getting that information out there, providing technical assistance, and New York BESS has been working very closely with CUNY to really be a conduit of information between vendors and questions that are being asked by permitting agencies. So moving right into New York BESS, who I thank for running this webinar today. They're really our industry-focused team member. Guidance on market rules and architecture and technology options, and of course today, interconnection issues. And New York BESS is available for one-on-one technical assistance under this program, so we encourage you to reach out to them and access all the resources they're putting out. Cadmus is our partner for verifying the field performance of the demonstration systems that we're funding under the PON 3541 that I mentioned. Case studies, validating both the technical and the revenue performance of these systems, which can really inform a lot of the other work that we're doing. And last but not least, of course, is ERS, which is our customer outreach partner, training on business models, use cases, heavy focus on just what are demand charges. And they are also very available and out in the field providing technical assistance for customers that have all kinds of questions about what is a customer that is really ideally suited for energy storage, and what are the characteristics of that customer, and should I be investigating energy storage, and providing a lot of the high-level analytics to work them through that process and give them the resources that we need. So high level, that's our storage program. We encourage you to visit the website to learn more. And with that, again, thank you to New York BESS for putting this together. And Bill, I'll turn it back to you to continue with the webinar.
Thank you, Ben. So I'm delighted to introduce our speakers today. We have an excellent panel for you this morning. We have speakers from the Public Service, from the Department of Public Service, from NYSERDA, and from Con Edison. And the people from the Department of Public Service and from NYSERDA are the leads for the two key working groups that are driving the changes in the interconnect process. And we have Andre Wellington from Con Edison, who is responsible for interconnection and will give you details on how interconnection is working within the Con Ed territory. So we have Liz Grisaro, who is the policy advisor for public service and co-lead of the Interconnect Policy Working Group. We have Jason Posey, who's the utility supervisor of the Department of Public Service, who's the co-lead for the Interconnect Technical Working Group. David Crudelli, program manager from NYSERDA, who's also the co-lead for the Interconnect Technical Working Group. And Andre Wellington, who is the manager of distributed generation and distributed resource integration for Con Ed. So I won't belabor right now. I want to get into the meat of the discussion. So I'm going to turn it over to Liz Grisaro, who is going to introduce the work going on to update the SIR, the Standard Interconnect process, and the work of the various working groups that we've been now talking about. So, Liz?
Very good. Thanks a lot, Bill. We're very happy to be here and glad to see so many people have joined us today. What we're gonna do for you is give you a high-level overview of the rule set that we call the Standardized Interconnection Requirements. That's abbreviated in these slides as the SIR, and we sometimes just refer to it as the SIR. We're also going to give you a look at the recent DPS staff filing made to the Commission on the 20th of December, which focuses on raising the cap under the SIR, or providing compensation for projects up to 5 megawatts, and also the addition of rules relating to energy storage systems. So we'll try to hit those two things today. You are probably all pretty familiar with interconnection processes. There's nothing especially unique about the structure in New York. The SIR rules provide a roadmap for the interconnection of generation up to 5 megawatts AC. We have a fast-track process for smaller projects under 50 kW. But of course, for larger or technically more complex projects, we have a more extended process that includes impact studies. And then at various points in the process, there are specific action deadlines that apply to both the project developer and the utility that is processing the application. So the basic components, the basic structure of the SIR from a developer point of view are basically you submit a complete application, and there are some rules to help you understand exactly what that means. You then can undergo preliminary and even a supplemental screening process. There's some optionality to that, but both steps are available. Then the developer reviews the results of the screening that come back from the utility, and it's possible to make adjustments at that stage. And at each step, our rules try to kind of focus the parties, both the utility side and the developer side, on finding solutions that will allow a project to progress, to advance towards construction. So if a solution isn't found at the screening stage, the rules require the developer either to commit to a larger, a full study, or to withdraw from the queue. And there are specific timeframes set around that decision. So if the project doesn't pass the screens and a solution can't be worked out, the project is likely to move to a system impact study in New York. We call that the Coordinated Electric System Interconnection Review, abbreviated as CESIR. You'll hear us use that term. So when you get to this stage, the SIR tells you exactly what data you have to provide to the utility. The utility has a fixed 60 business day time frame in which to turn around the study. There is a possibility of an 80-day time frame, but the default is a 60 business day period. And what you get back with the CESIR report are the identified impacts to the utility system and the system modifications that the utility has determined are necessary to accomplish the interconnection. You will also receive from your utility the cost estimates for those system modifications. This puts the developer now at another decision point. Once you get the scope of the work from the CESIR study and the related cost estimate, the developer has up to 180 business days to make full payment toward the utility's cost estimate or withdraw the application. We have a lot of firm off-ramps in our process because we want to make sure all projects are moving forward. Once you've paid for the utility construction work, of course, the next phase is to construct the project and then conduct verification testing and energize, and all of that is addressed in more detail in the rules. So that is a very high-level overview of the components, and I will ask my colleague Jason to tell you more about what we're proposing with respect to energy storage systems.
Good morning, everybody. What we're going to talk about today, for the SIR and energy storage, Some of the minor changes that we proposed in the 1220 filing were in Section 1, in the application process. We wanted to, obviously before the SIR did not include energy storage at all. So we had to include that in the introduction, in Part B for projects up to 50 kW, and as well in Part C for projects between 50 kW and 5 megawatts. So that was Section 1. We had some minor modifications in there. And then also in Section 3, we added some definitions and terms associated with energy storage to incorporate that. Getting more in depth for energy storage in the SIR, the concept was to use the existing process based on max output of the facility. In Section 1, Part D of the SIR, we added the rules for energy storage systems. There's an application process discussion, technical review, and contract and payment discussion within that new Part D. That's a brand new section that we added to the SIR specifically for energy storage. Associated with that, we included a new Appendix A1, which is a standardized interconnection agreement for energy storage. And then as well, there was a new Appendix K, which outlines energy storage application requirements, system operating characteristics, and initial market participation rules and requirements for energy storage. So these were kind of more of the more major modifications that we made to the SIR for inclusion of energy storage. Additionally, from the commission requirements, we did, as of last year, we did increase the threshold from 2 megawatts up to 5 megawatts for interconnection process, but the commission now is considering extending the new DER compensation to the 5 megawatt threshold. So that decision is pending. And the 1220 filing that staff proposed includes rules for that effort. So what comes next? The 1220 filing from staff was published for comments on January 10th, and I have to actually make a correction to this slide. Initially, we had a period for initial comments that were going to be due on March 12th, and then reply comments due on March 29th. Since the time we put these slides together, we actually made a modification to that where the entire comment period, the deadline is the 29th. So there isn't a two-step process anymore. It's the 29th is the deadline for comments on this. We are going to be shooting for the April session to move forward and propose these comments to the commission for adoption. And in the meantime, both the IT and IPWG group are going to be discussing some of the recommendations as well as comments that we know we're going to be receiving coming into us. The IPWG actually met earlier this week on the 17th, and their next meeting is the 27th of February. The ITWG group, the technical working group, has a meeting on the 31st of this month, and then again in March. And we are always open to additional meetings as needed for these groups, and there's probably a good chance that we might have to have some interim meetings in between those dates as well. And with that, I'm going to turn it over to Dave Credelli to wrap things up.
Okay, thank you, Jason. Good morning, everyone. We thought at this point it would be helpful to describe the framework that we've built and some of the resources that we've brought to bear to try and improve the interconnection process for all parties involved. Two of the main groups where that work takes place are the Interconnection Technical Working Group and the Interconnection Policy Working Group, both of which Jason just mentioned. pretty descriptive names. We're maybe not the most imaginative bunch. But the technical working group consists of utility participation and industry participation geared towards solving or coming up with consensus solutions to many of the really tough technical challenges that we face with interconnecting distributed energy resources to the electric grid. Most of the members of the group are power systems engineers and have a very strong engineering background and an understanding of the physics behind the interconnections. And we tackle a lot of the either existing or emerging problems that we see today by bringing to bear a number of resources, including some additional outside technical experts that we have that consult with the group, and looking across the industry to find best practices where they exist today and to create best practices where they don't exist, and then to enact them in New York State. We also have a policy working group, and that's really an outgrowth through a recognition that early on there were enough technical and policy issues that it really warranted having two separate groups. The policy group looks at the process, making sure that the process is reasonable, it's sensible, it makes sense, and it's efficient. And there's constantly some additional needs and tweaks to make to that process to keep pace with the industry. As the industry develops and technology develops, the process has to follow along as well. The goal for both of these groups is really to create a clear and certain pathway to interconnection that's both technically sound and rational in the process and requirements, and ensures the safety and reliability of the system while having the best possible and most permissive process and experience for DERs trying to connect. Much of the information that we create through those two groups ends up on our interconnection website, which is hosted by the Department of Public Service. The web link to that site is there on the upper left-hand side of the screen, although to be perfectly honest, the way I usually get there is by going to my favorite search engine and searching for NY space PSC space DG. So New York Public Service Commission DG. This is the first hit that comes up. So that's how I usually end up there. On that website, there is really a wealth of information related to interconnecting distributed energy resources to the electric grid. The interconnection queue is posted there near the top of the page, a number of reports that the different working groups have produced, and then sub-sites for the interconnection technical working group and policy working group. And that's where you'll find all of our meeting materials, our agendas, any documents that those groups have created, as well as the listen-in information for those that want to listen into those meetings. And finally, I thought I would end with just a quick look at the four leaders in the interconnection team across New York State, Jason and Liz, who are with us here today, and then my colleague Hutan Mulvaney at NYSERDA. Please feel free to reach out to us with any questions you may have on the process. We are a resource for you and to help guide you through the process, and also listen to ways that it might be made better or enhanced. So please don't hesitate to reach out to us. With that concludes my remarks today, and I'll turn it back over to Bill to move us along.
Thank you, Dave. So we're now going to move over to Andre Wellington from Con Edison, and Andre will be talking a little bit about Con Edison's interconnect, the existing interconnect, and how experience from that, walking you through the process a bit, and also talking a little bit about some of the things Con Ed is doing with respect to energy storage and energy storage interconnect here. So we're delighted to have Andre Wellington from Con Edison with us to speak next. So I'll turn it over to Andre.
Thank you, Bill. Make sure everybody can hear me. Good morning. My name is Andre Wellington, DG Ombudsman for Con Edison, also the manager of the Distributed Generation Group. So I want to walk through a couple of different items associated with energy storage. Just so you know, I think Liz and Jason and Dave spoke about some recent developments in the SIR going forward on how we'll treat battery storage in the application process and such. In Con Edison service territory, we have already installed energy storage systems. We have about a little we have about 18 systems for about a little over 2 megawatts installed on our system now. So we have been interconnecting battery storage, energy storage systems for a while. We have a good number of projects in the queue. So we have a little bit of experience in looking at these projects. I think there will be some more, the changes in the SIR that were spoken about previously will provide a little bit more clarity to the utility and help us process the applications a little bit better. So I think that's all a great and exciting thing for everybody in the state. So if we could advance the slide to slide 18. So basically what I'm going to describe today, I'm really going to just talk a little bit about the standardized interconnection requirements, the SIR. I think Liz gave a good background on it. I'll just touch on that a little bit. We'll also speak about the interconnection platform that Con Edison uses. It's the pathway for which a developer or a customer looking to install battery storage or energy storage system would apply with the utility. You'd fill out the information and we'd process the application in accordance with the SIR. Then we'll get into some common things to look out for in the engineering studies, which we call the CSERs. And also what to look for in verification testing. That's after the project is constructed, the engineer will come out to the site and really, go through the testing to verify that everything is as was stated in the application and everything's working properly. So in processing these applications, we see some common errors and common mistakes that are made that sometimes cause delays in these projects. So we just want to go over some of those today. And then finally, we'll discuss some energy storage system tariff changes that Con Edison has embarked upon, and we'll just give you an overview of what those look like. So, Bill, if you could slide to 19. Okay, so this, I don't have my glasses today, so this is hard for me to see too, but This is the Standard Interconnection Requirements, the SIR. Now, this is a simplified process flow. For all questions about the SIR, you should really refer to the SIR document on the website that was provided by Dave earlier. But this, we have this on our website, and we actually walk through with customers the actual flow of a application through our interconnection process and through the SIR steps. I'm not going to go over in detail, but just realize there are certain parts of the SIR where you can grab some information about a proposed project. So the pre-application report is a step that you can use if you'd like to learn about the proposed site where your battery storage or your DG project would be going. We encourage customers to use those. We encourage customers to talk to us about what they get back on those pre-application reports so they fully understand what they have and what site they're looking at and what the implications of that site are. Another thing I think Liz brought up I want to just bring a little attention to is the screening analysis review meeting that can happen after the preliminary screens or after the supplemental screens, but that just allows the customer, when you receive those results back, to contact the utility, get a meeting together, a conference call, so that you can understand the implications of the project, why the project failed to screen, what can be done going forward, what the next steps in the process are. So I think we strive to have some sort of, to achieve a level of visibility and transparency in this process. So whenever these meetings are set up so customers and developers can learn more and really understand exactly where their project is and what steps can be done next. So can we advance the slide to 20? So if you have done a distributed generation project prior to July 2017, you might have used our Project Center application. That was the method that we used to process DG applications prior to July. In accordance with the IOAP, which is a development path for the state utilities interconnection platforms, we have moved to PowerClerk starting July 2017. So if you go on the system now and and try to apply for DG or try to apply to put in a battery storage system, you'll be using PowerClerk. It's provided us with a number of different features, and some of those features will be definitely visible to you if you've used both systems, but the transparency, the flexibility of the system allows us to adapt to the SIR and the different changes. I think Liz mentioned that the SIR now is there are customer deadlines and there are action deadlines. So PowerClerk has allowed us to incorporate that in as well as customer choices. So after your preliminary screen, you have a set of choices that you can make to move your project forward. So I think that is taken care of by our new PowerClerk system. At the end, you'll see my contact information. If anyone has any issues when working through the system, definitely give us a call. But we think we've improved the application process vastly with moving in this direction. So, Bill, if you can go to the next slide. So, slide is a little bit off here, but really what we're just trying to show here is the one of the slides or one of the screens that you'll see when you're going to install, when you're going through PowerClerk and you're applying to Con Edison to install distributed generation or battery storage. So you can look, I won't go through all the fields, but you can look, one of the important fields towards the top is there existing DG at the proposed interconnection site. That's very important. You might see down below, this is a battery energy storage project, but we really need to know, is there other DG at the site? When we're studying distributed generation interconnection, especially battery storage paired with another type of DG, which we do have in our service territory, the engineers need to really know how these two types of DG will work together, so it's definitely important that you include that. If there's existing DG, the number of existing units, what type of DG it is, the existing DG. So that really helps in completing the engineering study, the CSER, in a quick and efficient way. If we don't have all the information, if the customer or developer applies and then we go back in our records and we see there's existing DG at the site, but it wasn't included in the application, that means we have to go back to the customer, we have to ask them for that information. Sometimes the customer, so it just elongs the process of studying the project. So it just adds delays to the overall process. So if you can just advance one, Bill. Okay, so moving forward, in the engineering study, this really occurs, it's called the CSER in the SIR, but it's the actual study of the proposed DG and the impacts to the system. The engineers will go over lots of different items, and we're going to go over some of the different things to look for, but realize that we're looking for in battery storage and how the battery storage or the energy storage system will affect the company's EPS, right? We're really looking at the load impact not only on discharging. The battery storage system can add load and it can add to the ability to export power. So we have to view both of those different aspects of the project. We also look at the protection and controls, the protective relay settings. Are there any voltage control mechanisms associated with the project? We have in the past utilized the smart inverters of some DG systems to alleviate some of the interconnection constraints that we have seen. So the fact that the project was incorporated smart inverters allowed us to use some of that capability to alleviate some of the interconnection concerns and voltage concerns that we've seen at certain projects. So it's important to definitely provide us all of that information during the application process. Other things that we look for, the make and model and additional technical details for the smart inverters, any disconnect switches, any breakers associated with the project. Really make sure that the 1-line or the 3-line diagram submitted has all of this information clearly outlined on it. It really just streamlines the process, and it cuts down on the back and forth where the utility has to request more information for the project. Moving forward, what do we look for in our engineering study? Now, I want to preface this slide with stating that in the new SIR that was proposed on that Jason spoke about earlier on December 20th, there is a whole application process for battery storage systems or electric energy storage systems. Now, when that, you can see, if you look at that version, you'll see that there are lots of different fields that might be requested for battery storage systems. What we're talking about here is what we did in the past prior to this version of the SIR going into production, which might be in April or later on this year. So we had to really ask for a lot of the information associated with battery storage systems. So we definitely were asking if it was standalone, which many of our installed systems now are. Is it a hybrid system? Is there some other DG that is being installed along with the battery storage system? Or are you adding battery storage to a site that already has another form of DG in operation? Those were very important questions. And then really we looked at the time of day usage of the storage system. How will it be operating? What kind of markets would it be in? Is it being put in place for a Con Edison demand response program? Is it being put in place for a NYSO program? We needed to kind of understand how the battery storage was being used and how it was being used in conjunction with other DG at the site. So I will say the battery storage, since it really wasn't clearly outlined in the SIR, there was a lot of going back and forth and requesting a lot of information so that we can gather all these data points and properly study the project. I think the new SIR, when it comes out, will ask for a lot of this information up front, so that will streamline the processing of battery storage interconnections in our service territory. One other thing to be aware of, and this really applies for all DG, we really request that the test procedures be devised by the customer or developer and provided to the company well in advance. That really just helps the engineer. It gets everybody really on the same page. It really shows how the engineer will test certain functionality of the inverters and the storage system and how it works out on the site. And it also lets the customer or developer kind of understand those exact steps, so they know exactly when the engineer gets to site what steps to follow, what the protocol is, what would be looked for after each step. For instance, if you kill the power to the inverter or you kill the power to the site or simulate that, what does the inverter do? Does the inverter shut off? Also, when you bring the power back, does it take 5 minutes for the inverter to come back on? These are different things. These are different steps that should be outlined in this procedure so that both sides or both parties are on the same page. So moving forward, another important step after the engineering study and those results are provided, the project would go into construction. After construction is complete, we have a site inspection for most large projects. So in that site inspection, we're really looking to go to the site, see the operation of the DG unit, make sure it's adhering to any requirements that were put forth, and make sure that what was supplied in the application is exactly what's on site. So when we go through that, we really do look at, well, before we even get there, a couple things to be aware of. If there is a third-party or city inspection that has to be completed, we really look to have a copy of that prior to testing. We just want to make sure that any permits that are required are already have already been received, especially when it comes to other types of DG, such as DG using natural gas. We really look to see that the service is installed and any necessary permits have already been received prior to scheduling the testing. We really would like developers and customers to ensure all labeling of equipment matches the three-line diagram. I think there have been many, many instances where we've taken the three-line diagram that we have associated with the project in our application platform. We print it out, we go to the site, and we don't see anything that's really labeled on the three-line diagram in the site. It's completely different. That really is a difficult thing to overcome, so our engineers have studied the actual layout based on what we've been provided. So it's really difficult to change that. So we often, in certain circumstances, we have to request that a new three-line diagram has to be submitted, and if in certain cases a new study or a modification of a study has to be done to make sure everything will fit the new diagram. This sounds a bit basic, I guess, but we have to make sure that we have safe egress at the location to test equipment. If you have a pit bull or you have a large dog or you have any other real safety concern that would get in the way of the engineer and the energy services representative from testing and looking at the equipment and inspecting the equipment, you really have to take care of that before they get on site. We don't want to put any of our employees in danger while doing the verification testing. And I guess I would say the last point, disconnect switches require a clear, visible break. The installation of DG equipment, especially in large DG projects, you need a 89L, a disconnect switch, and the disconnect switch has to, when open, be visibly open. We have to be able to see that, there's a clear break there. We have many instances where there's a switch and it's covered with a whole lot of equipment, and you pull the lever and open the switch, but a person coming up to the switch can't tell that there's been a clear break there. So that's something that we definitely need as part of the site inspection. And I don't have a percentage of how many projects fail that part, but it's a good number that have to go back and get that switch modified or replaced to pass that part. So advancing the slide. Okay, so I'm not sure if everyone can see the next slide, the verification test checklist.
Yes, it's up.
It's up? Okay. So the verification test checklist really is we have this on our website. This is a tool that we encourage developers and customers to actually use. It basically gives an idea of what we'll actually be testing when we get out there. It gives the developer and customer the ability to see, to go through the checklist before we get there. Make sure you check all of these different items, your disconnect switch, your grounding, the consistency of what's in the field to the submitted drawing. You can look up at the top, there's common things to look at before you even schedule the test, your drawing versions. In many large and complex projects, you have multiple versions of drawings that get uploaded because the project changes over time. There are certain things in the field that are found, certain configurations won't work, so a new version is uploaded or a new version is uploaded to the system. We just have to make sure that the latest version is the version that the engineer has and everybody's working off that version of the drawing. Make sure the proper people are on the site, attendants that are necessary to inspect the equipment, provide access to the areas that will need to be accessed. We think we actually developed this checklist out of a city collaborative that we've had for the Con Edison territory. We really looked at what kind of tools we can provide developers and customers to make sure that we're passing as many of these site verification tests as possible. And just one other thing about it, when you see the gray boxes, there are certain aspects of the project that will fail and will have to be re-inspected, and there are certain aspects that we can actually just request that the developer corrects it and sends it in to us, and then we can we can update our records. But if anything fails that has a gray checkbox, that normally requires an engineer to go back to the site and do a new inspection prior to the project being allowed to go into operation. So if we could advance the slide. So the last slide I have here, I just wanted to discuss some of tariff changes related to energy storage systems. Now this is specific to the Con Edison service territory. As you know, as I described earlier in the presentation, at Con Edison we have been installing battery storage systems for a while, or have been accepting battery storage applications for a while. Many of these applications utilize a reverse power relay. They were standalone battery storage associated with the customer load. They utilized a reverse power relay to not allow export onto the Con Edison system, so we were able to allow that. We actually made some slight tariff changes on our standby service tariff. I would say about a year ago, that allowed battery storage systems to be served with the standby tariff. So that's a customer employing battery storage at a site with customer load that can be serviced under the standby tariff. We have some proposed tariff changes that will specify the conditions in which standalone battery storage can export to the primary and secondary distribution systems. In the past, we did not allow battery storage to export onto our secondary. We're looking to make some modifications to our buyback service rate. Now that would allow inverter-based technologies, which include battery storage or energy storage systems, to export to the secondary grid. Now realize this is different. This is really looking at your standalone battery storage with customer load. So saying a commercial building that's installing a battery storage system, no other DG on site, and really looking at what they can do with that storage system. So this is allowing them to not only reduce their on-site load, but now when this goes into effect, it will allow them to export onto the secondary grid. Now realize any export that comes onto the secondary grid may require some modifications to the Con Ed system. That would be outlined in the CSER study or the engineering study. So this is really just looking for to establish tariff treatment that would allow for this and allow for the compensation of that battery storage. And the buyback service rate, if you're not familiar with our service class 11, that's our wholesale compensation rate. And one last item, standby reliability credit would exclude storage systems that are standalone, that are not connected to customer load. So that just really, I just wanted to give everybody an idea of how Con Edison is looking at battery storage. Now, this last slide, I just want to reiterate, this is not battery storage in combination with PV or battery storage in combination with other forms of DG. This is looking at standalone batteries, which we do have an interest in our service territory, and we have seen certain customers and developers installing. So with that, I think I've come to the last slide. If we can just go to the last slide. I just wanted to outline or highlight the coned.com/DG website. You can see a lot of this information there. A lot of useful tools for customers. You have my information there, my title and email address. So if you have any questions, you can always get in contact with us, and we can help as much as possible. That's all I have, Bill.
Very good. Thank you, Andre. Appreciate that. And just to remind people, I have one last slide I'm going to cover, but I want to remind people about questions. We've already got a number that are coming in, but please enter your questions into the chat function of the webinar, and we'll be answering the questions momentarily. And so we can be collecting them up. So you can please start to answer your questions as soon as you'd like into the chat function. And just to wrap up the presentation parts, I really appreciate the great presentations by Liz, Jason, Dave, and Andre. We're just to wrap that up a little bit. You heard that we have a lot of activity going on. We have the proposed interconnect changes, SIR changes that you can comment on. So we do encourage the industry to do that. New York Best serves as a conduit for that. Obviously, you feel free to comment directly, but you also can comment through us. We do also sit on the Interconnect Technical Policy Working Group, Technical and Policy Working Groups, so feel free to engage with us directly with your comments as well, and feel free to engage directly with the people you've heard from on this webinar. A couple of other resources and actions that are going on. Ben Falber outlined quickly earlier that we have the permitting roadmap and technical assistance going on, and we have the energy storage roadmap going on in the state. So that's activities that you're going to be hearing a lot about in the next little while. A very good source of that is the upcoming New York Best Conference on March 14th and 15th here in Albany, where you can hear quite a bit of detail on all of these areas, and further detail in the preliminary conference on the interconnection parts that we've been talking about today. Other resources through the soft cost team, our links are here. We have soft cost resources that the NYS has put together associated with fact sheets and soon to be released a guide to the value of stacking of energy storage in the state. We also have the RevConnect website where you can learn a lot about the non-wires projects and other things that have been mentioned today, and also, of course, the NYSERDA program links here as well. So with that said, we'd like to move into the Q&A section, and I think we have a few questions around combined things, combined systems. So one question was about if you have a CHP and solar, do you do that as a single application, or do you do that as two applications? So maybe I can frame the question on generally, if you have multiple DGs at a site, what is the approach under the SIR?
So this is this is Jason Bowsey. For multiple DG projects, that would constitute a single application, would be my understanding of it. So that there'd be a single application for if there were two types of distributed generation systems that were proposed. I know that as we move forward with the inclusion of energy storage, that's going to, a PV plus energy storage project is going to require separate applications. So, there would be two separate applications, one for the energy storage and one for the other type of DG. But if it was two types of DG, the way I believe the utilities are doing it now, and I don't know if it's clearly outlined in the SIR itself, but that would be one application.
It depends on common point of ignition.
Yeah, I mean, if Liz just asked about the common point of interconnection. If it was different, I think that would constitute a different application. So
very good. And maybe just to kind of follow up that, you alluded to it just now, but another set of questions here is people thinking about solar and storage together or solar standalone, and the idea of a hybrid system versus a standalone system. If you could possibly outline just how that's treated.
So again, we're looking at it if it's an existing PV project and is looking to add energy storage. There should be either an application already in or the project completed. That would be itself, and then the addition of energy storage would have a whole separate application, and the utilities would be combining that as they go through their process and doing a study based on both. Again, the important part with all this is a clear and defined operational characteristics as part of the Appendix K that we've proposed. And it kind of lays out what the plans of operation for that project's going to be, and lets the utility know what the developer and customer are trying to complete as a whole, as a project as a whole.
All right. And then for new systems, a new solar and storage.
For new, it would again still be a separate application for the energy storage part and the DG part. Again, it kind of goes along with the utility processes for, they have different processes for new services and efforts like that, with the energy storage being able to, output onto the grid by itself. We can look at that as a new load, so it's almost like a new service application.
Right. And then one more in that kind of general vein. This is actually a more straightforward one. There were questions around behind the meter devices, hot water heaters, storage behind the meters, not exporting, thermal storage, etc. And if you could just clarify on non-exporting, not being directly engaged here.
Yeah, I mean, we're looking at, as far as the SIR, it's what would be, equipment that's operating in parallel and exporting onto the grid.
Okay. And then Andre, there was a question around the engineering study requirements, and you started to get to the answer here, I think, when you mentioned that SIR simplifying the process. But the question really was, will all energy storage have to require an engineering study? And maybe you can just address how it's done now and proposed changes.
Sure. Just one quick thing associated with what Jason said. When you apply with battery storage and another form of DG, you fill out the two applications. But we have in our Power Clerk system, we have the ability for you to there's a section where you can fill out link the applications together so that we know they're both at the same site, and then we can move forward with an engineer studying that as a combined DGs. So definitely fill that out, get in contact with us, and let us know that installing two forms of DG at the same customer location. So, and to your answer to your question, yes, there are off ramps for DG projects going through the process. If a DG project passes a preliminary screen, it might not have to go for a full engineering study. And our projects that are below 50 kW do not require a engineering study in most cases. So there are projects that go through the interconnection process that don't require a study, but the more complex and the larger a project it is, the chances are the more effects it'll have on our system, and the more chances it'll require that study.
Very good. And then we also got some questions about small systems, residential 20 or below 20 kilowatt systems, and you outlined the difference in the SAR. Maybe you could expand upon the difference in treatment of say a 20 kilowatt system versus other systems.
So for a small residential energy storage system, we're looking at it following the same process as the existing fast track expedited process for DG, unless it comes up to a threshold where there's a control mechanism that would be needed. It would just follow the existing fast track under 50 kW process. And Bill, I just want to, and I don't know if, I think we had a question I wanted to just clarify. One of the slides that we had, it was, what comes next. I had actually second guessed myself, and the slides were actually correct on the comment dates for the filing, so that the filing was SAPA'd on the 10th of January. The 60-day SAPA period is March 12th, And then I think we added on an additional 2-week period for reply comments. So the slides are correct. I shouldn't have second-guessed myself.
I thought I made a mistake, but I was wrong. Very good, Dave.
Double negative.
So let's see, we have another question. Actually, I'll address this one to Andre. Question about changing of rate structures when you add storage. So if the question is when you're adding standalone storage, not without the DG, under what cases would you be required to switch to either the standby rate or to SC11? And I'll throw in the optional versus required into the question.
Sure. So our standby service rate is really a rate that's mostly associated with combined heat and power. It's basically we're providing standby service to that facility. So if the DG goes down, we will provide power to the building at any time. So we really we have associated battery storage with our standby tariff. So if you have a building, and you're installing a standalone battery storage system, you can. It's basically you'll be assessed under the standby service rates, but there are exemptions where if you don't feel that that's the best rate, there are exemptions for battery storage so that they do not have to go under the standby service rates. They can take our standard rates. So it's that optionality is available for standalone battery storage systems. Now the buyback service only really comes into play when the battery storage system is looking to export. Like they're looking to export some of that power to the grid so that they can supply. What I'm saying is they can supply the whole building load and still have some excess generation that they can push into the grid. We're looking to have that buyback service rate approved shortly, and that'll allow across our whole system for battery storage systems to export to the grid, and that will set the compensation rate, which is at our wholesale compensation rate.
Very good. Thank you, Andre.
Yep. Okay.
And we actually are at our time limit, so we're going to wrap this up. There are a few other questions. I do want to address, there were questions about the slides being available. We will make the slides and the link to recording available post the webinar. There were also some questions about the fire department DOB that Ben touched upon a little bit, and we will be putting out more information about that as we go forward here. I also, on these questions about standby rates and other things, the energy storage guide that will be coming out shortly, we'll have some more explanation about some of the reasons for making those choices that Andre was just outlining. With that said, we would strongly encourage people to do join us at Capture the Energy on March 14th and 15th. Will be a great opportunity to learn more about all these topics and the exciting things going on in the energy storage industry. And we also do have our survey coming up after the webinar, so please do take just a few minutes to complete the survey. I'd really like to thank our speakers again. They did an excellent job, and we really appreciate them taking the time to share this information with all of you today, and thank you for participating.